Okay, today we're going to be working on a little bit something that's a bit more fun than your standard garden variety solving unit circle stuff. There is work that we need to do today. Okay. Actually, no, it's not a new desk. It's actually an old desk. This is my desk at school. So I'm actually in the building right now. Yay. Thrill a minute. Yeah, loving it. Okay, don't get me started. All right. So I think we're almost here. Almost all here. I think we're missing like one or two. Okay, so let's talk about some trig identities. Oh wait, you're not. Give me a second. That's better. And let's get some focus. It's also a new camera, and I haven't beaten it yet. It'll learn. All right, trig identities. Now, what am I talking about with an identity? An identity is something that is equal to itself. Okay, it is an identity is something that is universally true. Now, what we're going to be dealing with first, before we get too deep into identities, is we got to first mess around with expressions and simplifications. But before we even do that, we have to list all of our trig facts that we know. Okay, so some of the things that we know already are that we have the sine, we have SOHCAHTOA, we know that. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And the tangent of theta is opposite over adjacent. Okay, great. Now, when we played a little bit around with the unit circle, and I don't want to dwell too deeply on the unit circle because, quite honestly, I think, with almost all of you being at home, you're going to have a unit circle in front of you. But if you only rely upon the unit circle that's printed in front of you, then quite honestly, you're going to be in a little bit of a trouble next year when you're not going to have it in front of you. All right, but now let's take a look at this and realize, let's hop over to tangent for a second and take a look. I've got opposite over adjacent. And if we look at sine and cosine, I also have opposite and adjacent with a common hypotenuse in my denominator. So I say the following. If the tangent of theta is opposite over hypotenuse, I'm going to multiply it. Sorry, opposite over adjacent. I'm goofing it right away. That was nice. Nobody yelled at me. Should all yell at me. Opposite over adjacent. I'm going to multiply it by 1. Because 1 over hypotenuse divided by 1 over hypotenuse, whatever the hypotenuse is, because we know it's not 0, is 1. Anything divided by itself is 1. So this leads us to say that the opposite over the hypotenuse is equal to divided by the adjacent over the hypotenuse. And now, using the identities that we had already defined, we see that the tangent of theta is equal to the sine of theta divided by the cosine of theta. And this is one of our very important identities. Okay. So off the bat, right away, we've got these three. and this guy. All right, fantastic. Now, let's go ahead and define some of my reciprocal identities. So 1 over the sine of theta. This is the cosecant of theta. It is pronounced cosecant. 1 over the cosine of theta is the secant of theta. Okay, that's how you pronounce it. Secant, not second or secant or any other cracked out pronunciation. And we are not British. So it is pronounced secant. And finally, 1 over the tangent of theta is cotangent. Okay, is not pronounced cot. I will reach through the internet and smack you. Okay. So these are some of the identities that we need to know. All right, fantastic. Okay, so now let's go back and look at my unit circle. Now, if we were to pick any angle on the unit circle, I don't really care, but I'll make one nice and easy inside the let's say the first quadrant. For a given theta, we know that the hypotenuse of the unit circle is the radius of the unit circle, which is 1. Now, going back to when we learned the unit circle last week, I told you that if I asked you for the sine of an angle, I was asking you for the y value. And if I was asking you for the x value, I was asking you about the cosine, or asking about the cosine, you're thinking of the x. So this is how we were thinking of our unit circle back in the day. And this gives us our most important of all identities. It is not only used in mathematics, it is used in so many other fields besides trigonometry. It's, for crying out loud, it's used in biology. Okay, and this is the Pythagorean identity. And it is the sine squared of theta plus the cosine squared of theta is equal to 1. Now, just to talk about this the superscript notation that I'm talking about here, this is equivalent to saying the sine of theta squared. That is not the same as the sine of theta squared. Okay, this is saying pick an angle, take the sine of it, and then square that number. This is saying take an angle, square that angle, and then take the sine of it once. Okay, so I need you to understand that there is a distinction between these two. Okay, and that I am talking about this guy is this guy. Okay, all right. How about just touching bases? How do we feel today? Thumbs. I don't see any shiny happy faces today. I don't even get to see Ferris. Oh, cool. Thank you so much. All right. Now, let's go ahead. All right. So what we will be working on today. And what I would like to do is just practice some expressions. So secant of theta minus cosine of theta times the cosine of theta. All right. So the whole purpose of this is to basically convert this rather, thorny, complicated looking thing, not really that complicated, but trying to see and figure out what this guy actually boils down to, because we have these identities that we've pulled out. Okay. All right. So let's do one or two things first. Do yourself a favor and realize that secant is 1 over cosine. Now, because I can distribute, 1 over cosine times cosine is 1. And cosine of theta times cosine of theta is cosine squared of theta. Now, you might say, well, the heck, that's a really nice, simplified, boiled down thing all by itself. But if we pull back a few moments ago to our Pythagorean identity and take a close look at this, from this, we get two other identities. Solving for cosine, moment, I'm just going to pull this off. Cosine squared of theta, according to, oh, I love my focus. I'm just going to have to, me and my webcam are going to have words. All right. Solving for cosine, I get 1 minus sine squared of theta. And taking that identity again and solving for sine gives me, or sine squared rather, gives me 1 minus cosine squared of theta. So between this and these two, we have some very nice identities that allow us to boil things down very nicely. Okay, so coming back here to the problem, now I've got this. This we saw before is equal to sine squared of theta. And now you really are done. Take a second, tattoo that to the inner part of your eyelid, 1 per eye, and see how we applied it. Okay. Now, believe it or not, there's more than one way to skin a cat. And if you've ever tried to skin a cat, you really do know that there has to be more than one way to do it. So let's go back to that problem. And just for giggles, I'm going to show you that there is another way to solve this problem. By analyzing what's inside my parentheses, I attempt to get a common denominator. Now, simplifying, now that I've got my common denominator, now you can see that my cosines cancel, and I'm left with 1 minus cosine squared, which is sine squared. So one of the important tools, and I really wanted to make sure that I showed you this, finding a common denominator is a really, really useful tool when solving these problems, okay? Because it allows you, most importantly, to turn two terms into a single term. There aren't a lot of ways that you can do that. if you think about it mathematically, in order to turn multiple terms into a single term, you have to do some pretty fancy math in a few cases. Okay. This is only one of the few tools that simplifies the number of terms from multiple down to single. And when you're looking at a problem and you say to yourself, I've got lots of terms, you might want to ask yourself, how can I reduce the number of terms from 2 down to 1? All right, let us proceed. All right. Ooh, fun times. All right. Oh, that one's no. We'll okay. One thing at a time. Let's just do some simple ones first. Secant of theta all over the tangent of theta. Now, in this situation, when you're dealing with reciprocal identities, okay, it is generally a good idea to break down your secants, cosecants, cotangents, and sometimes tangent into just plain old sines and cosines. Now, before we go too far or too deep into this, I want to talk about some people's handwriting. Because what winds up happening here is that I wind up with a totem pole of mathematics. Love my webcam, people. One moment, ladies and gentlemen. I'm going to fix this thing right now. And I'm going to mute so you don't hear me curse. Okay. Thank you for your patience. So my suggestion is for your secants, cosecants, secant, cosecant, cotangent, and tangent, not always with tangent. Sometimes you can get away with not dealing with tangent, but break them down into just sines and cosines. Now, this is where space is a good thing. Secant is 1 over cosine. Tangent is sine over cosine. Now, when writing what is called a compound fraction, okay, it is important that I be able to tell where your numerator and your denominator end, okay? Because what I don't want to see, think of this, think about this. Just pause for a second. I'm going to go off on a tangent. Haha. Watch. That is a totem pole of math. I have no idea if this is 1 all over A divided by the fraction B over C. Is this 1 all over A over B, all being divided by C? See where I'm going with this? Esto es problema. This is muy malo. Okay. Esto matemático es basura. Gracias. Okay. So please do yourself a favor. Do me a favor. Don't make me work too hard trying to figure out what passed between your ears. So now I'm going to perform. Now there's 2 ways you can do this. You can do this as a double rainbow, And now I wind up with cosine of theta all over cosine of theta times the sine of theta. And now those two reduce down to 1, and I'm left with 1 over the sine of theta, which is cosecant. Now, please note the fact that I liberally used lots of space. Okay. It may be the final frontier, but it's not in scarcity. So please use space to make sure that I know that this is one set of lines and this is another set. This is another. I ran out of room here, which was bad. But the point is that if all of this ran together into one giant totem pole of mathematics, I'm going to tell you exactly what I'm going to do with your paper. It's going to be this. All right. Moving on. Oh, thanks, Herminio. I get a low B on my Spanish from Herminio. That's rough, dude. You know, I never took a Spanish class. Nope. You know who taught me Spanish? A bunch of kids who I was trying to teach math to. Yep. I learned more Spanish from them than they learned math from me, but that was okay. But yeah, really. But yeah, on the 100th day of class, I actually was able to teach the whole thing in Spanish. Badly, but I did. Okay, so moving on. Now let's do some more. Okay, let's get funky, shall we? 1 plus cotangent squared theta times the tangent squared of theta. Okay. So you're going to do this one on your own. Here's what I suggest. Break everybody down first before we do, like, before we start getting exciting different identities and things. Break everybody down into sines and cosines and boil this thing down just with sines and cosines. Get common denominators, clean this puppy up. Good point. So what is cotangent of theta in terms of sines and cosines? So remember, cotangent was the reciprocal of tangent. So that is the reciprocal of sine over cosine to just be cosine of theta over sine of theta. So cotangent. Just to say it. No, you look like a student. You have two terms. You don't. No, just get a common denominator. I hope you don't mind talking while I don't care. Cool. Under normal working conditions, this room is a zoo. Are we all dying? You lost your denominator? All right, let's dive into it a little bit. Cotangent squared is cosine squared over sine squared. Tangent squared is sine squared all over cosine squared. Okay, now there are two ways you can go about this. You can get a common denominator now and then distribute, or you can distribute and then get a common denominator. Quite honestly, I don't care. But let's just go ahead and distribute in. Sine squared of theta. Now, this is the reciprocal of that, so it just becomes 1. Now let's get our common denominator. And what happens to my numerator? And now the reciprocal of cosine is secant. So this is secant squared theta. So these are fun. They are puzzles. Okay. Now, oftentimes you will see these not as an expression, but as an equation. And you will be told what to turn the other guy into. Okay. So I'm going to tell you okay. Okay, there was a question in the chat and I have to go back and address it. Hold on for a second. The question was, how do you go from the bigger fraction to the other? This one? When the cosine was on the top, you're talking about from this line to that line? Because sine squared plus cosine squared is the Pythagorean identity. That's equal to 1. This cosine down in my denominator didn't change at all. You see it? That's that identity that we talked about. That's the identity that, you tattoo on your arm. Okay? Yeah. Okay. So now let me talk to you about this, because this is just basically the same kind of thing, except that I'm already telling you what the answer is. And actually, this one's going to run out of paper, so I'm going to rewrite it on vertically, all right? Just because I know I'm going to run out of space. Okay, so here's the roll. Here's the deal, guys, ladies and gentlemen. You get to pick a side. I don't care. You want to pick the left? Fine. You want to pick the right? Not good. Well, the right side's not, well, I'll explain why. The left side is going to turn into the right side. Under absolutely no circumstances whatsoever are you allowed to move things across the equal sign. If this is your target, it is verboten. You do not come near it. You do not multiply anything to it. You don't touch it. It stays perfect and pristine throughout the entire problem. And at the very, very end of the day, you will have cosecant squared equals cosecant squared. So the whole job is to transform, using algebraic tools, this left-hand side only into some, avenue of math, so that at the very end you have cosecant squared equals cosecant squared, and you're done. Okay, so let me walk this one through you, because there's like 6 different ways of solving this problem. And the cool thing is that you know where you're going. So kind of like all roads lead to Rome kind of a thing. Okay, all right. So I'm going to go ahead and break up this fraction. So 1 over tangent squared, and then tangent squared over tangent squared is just 1. So now I'm going to go ahead and clean this guy up a little bit. And I'm going to say that this is the cotangent, which is cosine squared of theta all over sine squared of theta plus 1. Now, I did that because I knew that I could clean up a whole bunch of tangents and just turn all that junk into a single one. But now I've got 2 terms, and on the right-hand side, I've got 1 term. So your job is to get from 2 terms to 1 term at the very least. And the way to do that, to have somebody just unmute and say it. We've done it 6 times already.
Common denominator.
Yes, you get a common denominator. And drum roll, please, Emma. What's my numerator equal?
1.
1. And can anyone tell me what 1 over sine squared is?
Cosecant.
And you're done. So never did I touch the right-hand side. And I'm not asking you to write it out every single time. I mean, that's just a waste, dude. Okay, but just leave it alone, leave it blank. I'm happy. Okay, that's cool. Do it at the beginning, do it at the end, and we're cool. Okay. Okay, before we go any further, questions, issues, moans, whines, complaints. How are we feeling so far? Scale of 1 to 5. I love the degree of resolution with some of these values. 3.85. Okay. Not 3.86, 3.85. Very good. Okay. Más trabajo. All right. Ooh. Okay, I think you guys can do this one. It's horrible. Go ahead and give me a thumbs up when you found it. Okay, so this one was hopefully kind of straightforward. 1 minus sine squared, we knew that is cosine squared. 1 minus cosine squared, that's sine squared. And that is cotangent squared. Okay. Let us prove the following. Oh, did I just secant squared? Oops. Oh, I could have kept it. 1 plus tangent squared equals secant squared. Thumbs when you get it. Mhm. Is it coming along?
Mr. Ronco,
Speak to me.
why is cosecant with sine and not cosine?
Good question. Okay. It all comes down to the geometric interpretations of why they are called sine and cosine. And I believe it or not, in the pop quiz that you're about to take in about 5 minutes, you will actually see that illustration at the top of the quiz. And I would be happy to explain to you all of those symbols and terms and all those things. So just wait. Thank you, Emma. By the way, the whole class, I just want to let you know, Emma and I planned that. We weren't going to have she came up to me and said, I think I need a pop quiz to help me learn my unit circle. So I just want everyone to know, everyone should say thank you to Emma, because now we're all going to be able to know our unit circle better. Thanks, Emma.
Yeah, thank you. I just need a little bit more practice, get
Yeah.
my mind thinking.
Yeah. All right. Big fan. Yeah, that was great. Thanks. Cool. All right, so let's do this. 1 plus sine squared theta over cosine squared theta. Get a common denominator. I'm just going to skip that step. I mean, I think we all know how to do that. If not, we're in trouble. And now I've got 1 all over the cosine squared of theta. And that is secant squared of theta is equal to secant squared of theta. Now, this is one of a kind of an extension of Pythagorean identities that addresses tangent. The next one I'm going to show you, you can also tattoo very small somewhere on your arm. But this is another one that's very, very useful for some people. Some people use it all the time. Quite honestly, I don't really care. I just do all this anyway because it's good practice. So you can keep this one handy along with your other Pythagorean identities. So now will you please do the following? 1 plus cotangent squared of theta is equal to the cosecant squared of theta. And don't lose all of your thetas. Yeah, please. That's like having a square root sign with nothing under it.
Very small things.
Okay, so this one rolled out very much like the last one did. 1 plus cosine squared theta plus over sine squared theta. Sine squared theta plus cosine squared theta all over sine squared theta. 1 all over sine squared theta is the cosecant squared of theta. Okay. So this is another one that's also very useful for some people. If you'd like to keep it handy, you're welcome to it. All right. So you have 45 minutes to do this quiz. Why doesn't everybody hop on to Canvas and take Emma's quiz?
Well, since it's my quiz, can I just not take it?
No. We're all going to be comparing our scores to you. Just kidding. Just kidding. No.
Mr. Rocco, there appears to be a problem in that I don't see anything on the Canvas page. Problem. How different one says it says to do nothing.
Yeah, no calculators. Use your brains, ladies and gentlemen.
Something you are allowed to start papers.
Yes. No calculators, no notes. Do this for real.